In the competitive environment of academic assessment, many students rely on late-night cramming and rote repetition rather than on strategies that align with how the brain naturally learns and remembers. Advances in neuroscience, particularly in our understanding of neuroplasticity, the brain's ability to reorganize itself by forming new neural connections, offer practical, evidence-based methods to improve exam recall and long-term retention. By deliberately shaping study habits to harness neuroplastic processes, students can optimize learning efficiency, deepen understanding, and increase the likelihood of achieving top grades. Understanding neuroplasticity and memory. Neuroplasticity describes how neurons and their networks change through growth, pruning, and strengthening of synaptic connections in response to experience and practice. Learning forms and consolidates memories by stabilizing patterns of neural activity. Repeated and varied activation of the same circuits increases synaptic efficacy, long-term potentiation, while disuse or lack of reinforcement leads to synaptic weakening, long-term depression. Memory itself is not a single unified faculty but comprises stages: encoding, initial learning, consolidation, stabilizing memories, and retrieval, recalling information. Each stage can be influenced by behavioral techniques that promote adaptive neural remodeling. Principles for rewiring study habits. Spaced repetition. Distributing study sessions over time leverages the spacing effect, which enhances consolidation and reduces forgetting. Each encounter with material reactivates and strengthens neural traces, making retrieval more reliable. Scheduling brief review sessions at expanding intervals, e.g., 1 day, 3 days, 1 week, 1 month, is far more effective than a single massed session. Active retrieval practice. Testing oneself, through flashcards, practice problems, or self-quizzing, forces the retrieval process and strengthens the neural pathways responsible for recall. Retrieval practice not only assesses knowledge but also produces greater long-term retention than passive study methods like rereading or highlighting. Interleaving and varied practice. Mixing related but distinct topics during practice sessions. Interleaving promotes discrimination between concepts and prevents overfitting of cognitive strategies to a specific problem type. Varied contexts and modalities, visual, auditory, written, verbal explanation, encourage multiple neural representations, improving flexible recall under exam conditions. Deep processing and elaboration. Meaningful encoding, linking new information to existing knowledge, explaining concepts in your own words, or generating examples, creates richer, more accessible memory networks. Elaborative encoding engages broader cortical areas, facilitating integration across domains and supporting application-based exam questions. Multisensory engagement and visualization, incorporating diagrams, mind maps, and verbal explanations creates multiple retrieval cues across sensory modalities. Mental imagery and spatial mapping of information can harness hippocampal and parietal networks involved in memory and spatial organization, aiding recall during high-pressure testing. Sleep and consolidation. Sleep, especially slow-wave and REM stages, is crucial for memory consolidation. During sleep, neural replay and synaptic reorganization stabilize and integrate learning. Prioritizing regular, sufficient sleep after study sessions significantly enhances retention and application of complex material. Stress management and emotional regulation. Chronic stress impairs prefrontal cortex function and hippocampal-dependent memory processes, undermining both encoding and retrieval. Techniques like mindfulness, brief physical activity, and structured breaks reduce cortisol levels and improve attentional control, creating a physiological environment conducive to plasticity and reliable exam performance. Progressive difficulty and desirable challenges. Engaging with problems that are just beyond current ability. The desirable difficulty framework stimulates adaptive plastic changes. Struggling with challenging material and receiving corrective feedback strengthens problem-solving circuits and prepares students for novel exam tasks. Practical study plan grounded in neuroplasticity. A practical plan integrates the above principles into a weekly routine tailored to specific course requirements. Initial encoding. Begin with focused, distraction-free sessions that combine concise reading with note-taking, emphasizing elaboration and concept mapping. Spaced reviews. Use a spaced repetition system, digital or paper-based, to schedule reviews at increasing intervals. Keep sessions brief, 20 to 40 minutes, and focused on active retrieval. Retrieval sessions. Daily short quizzes or flashcard runs, with weekly full practice tests under timed conditions to simulate exam stress. Interleaving. Rotate study blocks among related topics rather than repeating one subject until completion. Sleep-in breaks. Study earlier in the day when possible, and ensure 7 to 9 hours of sleep nightly, with naps after intensive sessions when feasible. Stress reduction. Incorporate short mindfulness exercises, light aerobic activity, and nutrition, hydration routines that support cognitive function. Measuring progress and adapting. Track performance objectively, quiz scores, timed problem completion, and practice exam results, to identify weak areas and adapt the spacing schedule or practice type. Neuroplastic changes are incremental, consistent, deliberate practice yields measurable improvement over weeks and months. Small, data-driven adjustments to difficulty, modality, and timing will accelerate gains and prevent plateauing. Conclusion. Neuroplasticity reframes learning from passive absorption to an active, sculptable process. By aligning study strategies with how the brain encodes, consolidates, and retrieves information, through spaced repetition, retrieval practice, interleaving, deep processing, sufficient sleep, stress management, and progressive challenges, students can rewiring their neural pathways for superior exam recall. These methods not only improve grades but also foster durable understanding and transferable skills that extend beyond any single test or course.